Okay, Professor Diaz here, and in this video I want to continue the discussion on the production possibilities frontier, but talk about a curved production possibilities frontier, okay? So in this video we're going to assume that this country can produce either 4 cherries or 4 blueberries, okay? So it's a linear relationship in terms of they can produce a total of 4 or cherries or a total of 4 blueberries. Now, in the last video, we would have drawn the production possibilities curve to show something like this. This is a straight line. The reality is, in production, the production possibilities frontier is curved, and so it would look something like this, okay? The production possibilities curve would look something like this. This is the curved production possibilities frontier. It's the same line. Everything I said in the prior video still applies. The difference is it's curved, okay? Why is it curved? The reason it's curved is that as you produce more of a good or service, you become less efficient at producing that good or service, okay? We call this diminishing returns, right? We become less efficient at doing something. So let's say this is the production possibility frontier for the United States, the USA, okay? So this is the production possibilities frontier, and this is just a model, just an example, but let's say the United States can only produce 2 goods, okay? They can either produce cherries or blueberries. Now we have to employ all of our resources to those 2 goods. The reason it is curved is because as you produce more of a good, the resources you have become less effective at producing those goods. So the 4 major types of resources are land, labor, capital, and entrepreneurial spirit. I'll jot those down briefly. Land, labor, capital, and entrepreneurialism or risk, adventure, entrepreneurial spirit, ideas. These are the 4 factors of production, the 4 resources, right, that come together for production. So let's say this is the USA and we have to put, let's just start with labor, for example. All of our labor in producing cherries. We want to produce all cherries, okay? So we want to produce 4 cherries and no blueberries. The question is everybody equally good at producing cherries, or are some people blueberry farmers? And the answer is, because of the law of diminishing returns, some people are better at growing blueberries than they are at growing cherries, okay? And so you can have everybody grow blueberries or cherries, but as you make people specialize more and more, you have to give up more of something else to get it. So let's look at one point, say here. Excuse me. Let's look at one point, say right here. So at this point on the production possibilities frontier, we can produce 3 cherries and we can also produce 3 blueberries. Now, what's the opportunity cost of producing 1 more cherry? Okay, so we want to move from this point to this point. We want to produce 1 more cherry. Well, the opportunity cost as you slide along the curve is all 3 of the blueberries. So as we produce just 1 more cherry, we have to give up 3 blueberries. And so this would be the opportunity cost of producing that 1 cherry. Conversely, if we're looking at sliding the other way, let's say we want to produce 1 more blueberry. So we want to go here. 1 more blueberry, so we produce 4. How many cherries is it going to cost us? Well, we have to slide all the way along the line, which means it's going to cost us all 4 cherries, okay? So this is the same going either direction because of the curve, because of specialization, right? If you're just moving from, say, here to here, right, there's an increase of cherries and just a moderate loss of blueberries, right? But the farther you slide up the curve to where you're producing exclusively cherries, the more blueberries it costs you. And the same is true going this direction. This is because of the specialization. Again, if we said, hey, everybody in the United States, you have to produce cherries. Well, by the end here, we're not producing people that are good at producing blueberries are forced to produce cherries, right? And so, yes, we can increase our cherry production, but our best blueberry growers are stopping producing blueberries and are forced to produce cherries. As we go from 4 to 3, now our best blueberry producers stop producing cherries and they can start producing blueberries again, right? And this is the same for other resources, say land, okay? I like using the example in this case of apples and oranges. So let's say this is an orange, right? We know in Washington State, that we are very good at growing apples. In Florida, they're very good at growing oranges, right? So if we could grow oranges in Washington, just not very well, right? And they could grow apples in Florida, but not as well as we can grow them here in Washington. So if in the USA, we made all of our land, one of our resources, produce apples, towards the end of this apple production, it would cost us a lot of oranges. And conversely, towards the end of the orange production, it would cost us a lot of apples. Okay, this is because of diminishing returns in production. Okay, this is why the production possibility frontier is actually curved. When we start talking about other applications, we're just going to assume it's a straight line because it makes the math simple and the opportunity cost constant. When we're talking about a straight line, the opportunity cost is constant from any point to any other point, right? But when we're talking about a curved line, the opportunity cost changes depending on what point to what point you're running. So the important thing to know is that a production possibility curve, a production possibility frontier is curved in reality, right? The more specialized you get in a single good, you're the less efficient you become at producing that good. However, for a lot of the calculations and calculating opportunity costs, we're going to assume straight production possibility frontiers. I hope this makes sense. In the next video, I want to talk about the difference between production efficiency and allocative efficiency.